Good morning, class, and welcome to Geometry AI. Today we're in lesson 1.4, perimeter and area. Join me on page 47. We are on page 47. On page 47, you will see a blue square grid where you will draw the Explorer ABC. Okay? So I've drawn mine in red. On your paper, yours is blue. Go ahead and draw your y-axis and your x-axis right through the middle. We're gonna start by drawing a quadrilateral ABCD, and I'm just gonna make this simple. So I'm gonna go 3, 3 is gonna be point A. Then I have 3, -3 is gonna be point B. Then I have -3 is going to be point C, and finally I have -3, +3 is going to be D. So notice before we move on that this quadrant is both positive, this quadrant is both negative, and this one is only one negative depending on the y in this quadrant and the x in this quadrant. Now, we're going to go ahead and draw our sides. And there we have a square. It's a perfect square. So we're going to make several observations, okay? We did this part. Yay, it was interactive. For part B, we're going to make several observations. So we can say square A, B, C, D. Notice in geometric annotation or geometric writing, we can put the shape followed by the vertices, okay? So if this was a triangle, for instance, we would say triangle ABC. If it was a parallelogram, we could say parallelogram ABCD. So it's kind of cool how you can actually draw the shape itself and then the 4 points and use that to name the object, okay? So this is square ABCD. Go ahead to explain how you can find the perimeter, then find the perimeter. Okay, so perimeter, peri means around, meter means measure. So perimeter is just the measure around the object, okay? Measure around object. We can also always refer to perimeter as the fence, okay? So I always refer to perimeter as a fence because we're seeing the distance around the object or how much it would take to fence in or enclose the space. We're not thinking of how much space it takes up, how big it is, nothing of the sort. We're only thinking of the outer lines and the distance those lines travel, the fence, okay? Now let's go ahead and count. We have C going from -3 to +3. That travels a total of 6. Here we go from -3 on the y to +3 on the y. Again, travels 6. 6, 6. You can count 1, 2, 3, 4, 5, 6, 6. You can count 1, 2, 3, 4, 5, 6. You can use your formulas, subtraction, what have you. You will find 6. With the perimeter, all we do is add. So 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So the distance around the object is 24 units. Again, 6, 12, 18, 24 units. We just counted. Perimeter is always going to be addition. So whatever you're doing perimeter, it should just be addition once you find all the sides. You might have to use a length formula or distance formula that we learned yesterday if it's a complicated object, but usually we can just do addition and we'll talk more about that. finally, we have D. Explain how you find the area. Okay, area. Well, as the name alludes, area is the total space or the total area that the object takes up. So we can write total space. This is multiplication. When we're doing area, it's multiplying, okay? There are different formulas for different shapes, and we're going to touch on that in 1.4. So each shape has its different area formula. Lucky for us, the formula for a square, the area of a square, is base times height, okay? So that means the area of square ABCD is a height of 6 times a base of 6. 6 times 6 is 36, okay? So that means our area is, we'll write it right here. Now pay attention to this part, 36 units squared. It's essential that we write the squared because space is a two-dimensional measurement. This square takes up 2 dimensions of measurement, okay? The same way that this paper represents a 2-dimensional flat surface, we can't say this paper takes up 1 dimension of space because it has a horizon, it has a vertice, okay? It's a flat object. So whenever we describe area, it always has to be with a square, okay? We didn't have that for perimeter because this is length, okay? That is part 1. So we're gonna flip over to page 48. This page is kind of exciting, I like it. Let's go ahead and erase here. So most importantly, while I'm erasing, you're gonna look at page 48. On the left-hand side, you see the number of sides and the type of polygon. So read it with me. 3 sides is a triangle, 4 sides is a quadrilateral, we have a pentagon. Hexagon is 6 sides, heptagon is 7, octagon is 8, we have a nonagon is 9, decagon is 10, dodecagon is 12, and then n-gon. So that means if it was 13 sides, it would be 13 gone, 14 gone, 100 gone. That's literally what that means. So let's look at page 48 now on example 1, classifying polygons. So this is example 1, classifying polygons. There are 2 types of classifications in this chapter. We have our regular polygon, which we call convex. And then we have our irregular polygon that we call concave. Now, at this point, you might be a little bit like, okay, I'm never gonna remember this, Mr. Baird. Thanks for that information. It was quite confusing. It's not that confusing because if you have a house, this is your house. When we look at this house, we go, oh great, yep, everything is fine, no big deal. Suddenly there's an earthquake, right? What would you say if there was an earthquake and your house finished off looking like this, right? The roof fell in. If the roof fell in, you would literally say, oh no, the roof of my house caved in. You would say this caved in, okay? All that means is that when an object goes into itself, think about it, when an object falls into itself, it's concave. If the object has strong sides, it is convex, okay? So here, let's think of example A. For example A, we have this figure right here. The sides have fell into each other, and we know that because if we were to extend the sides, it would cross into the object. Here, if we were to extend the sides, they would not touch the object. But here, if we were to extend the sides, it would touch, and that would make it concave. Because the object touches the inside, it is concave. Example B, we have a hexagon. All the sides do not go into the object, so B on page 48 is convex. Finally, we have our page 49. Now this page 49 is the essence of chapter 1.4. Go ahead and look at page 49. Circle, highlight, put stars around perimeter and area formulas. So here you have your triangles, squares, rectangles, and parallelograms. Again, here you have the perimeter and area formulas for triangles, squares, rectangles, and parallelograms. That's important. Go ahead and take a look.